This is my demonstration for the crowd simulation system implemented in Unreal Engine 5. What you're looking at here is around 800 zombies running very poorly. This is expected when having so many characters processing at the same time without any optimization techniques. As the game is running at such a low frame rate, the FPS counter is inaccurate. So if we show the engine's FPS using the console commands, we can see that the game is averaging around 4 FPS with a frame cost of 200 milliseconds. Next, if we look at the same number of zombies, but using optimization techniques, we can see that the FPS becomes much more stable, averaging around 15 FPS. This is due to the number of optimization methods implemented. The primary technique used is a form of level of detail adjusted to work with AI behaviors. The AI level of detail works by calculating the enemy's position from the player and changes each zombie's LOD state to the calculated LOD state. This can range from LOD level 0, where the enemy is fully active featuring animations and movement behaviors, to LOD 3, where the enemy is inactive and no logic or rendering is done on that character at all. Some other optimization techniques used are animation budgeting in order to reduce the cost per frame. Animations are throttled based on the priority to the player, and further distant enemies feature slower animations to save system resources. The AI also features 2 special LOD levels handled specifically by 2 other optimization methods. LOD 2 is for the zombies who are not actively being rendered. This is to pause behaviors for enemies that are out of the player's viewport, done by checking whether the character was recently rendered. LOD 1, however, is reserved for enemies who are within a mid-range distance where they need to be visible but are far away enough that the AI behavior is not needed. In this state, the enemies remain frozen by changing the skeletal mesh into a static mesh, creating a form of imposter. This method also allows the use of Unreal Engine's Nanite to take advantage of static meshes, as Nanite currently does not support skeletal animations. If the player comes within range of the enemy, they are returned back to the LOD 0 state, where the static mesh is replaced by the skeletal mesh, allowing for animations, and their logic is resumed. To prevent so many zombies at close range from processing at once, an active enemy variable has also been implemented. This is done by giving the player character a sphere collision that checks for overlaps with the zombie class. If a zombie is detected, it is added to the active enemy list, which sets these zombies to LOD level 0. Once this list reaches its maximum, any other zombies within range have their LOD state forcefully set to LOD level 1, becoming the same husk state as mid-range enemies. Now, if we have a look at 1000 zombies, we can see that the frame rate has fallen quite a bit. However, being able to process and render this many zombies at once is quite impressive given the old hardware used to create and test this project on, showing the importance of optimization techniques when handling crowd simulations. Moving to look at 500 zombies, the game reaches a much more stable 30 FPS average, showing the sweet spots of this implemented technology. However, I believe that being able to process 1000 zombies could be achievable at 30 FPS by using more advanced techniques such as geometrical LOD being applied to the models, and by taking advantage of other Unreal Engine components such as instant static meshes. Some other techniques I would like to explore are object pooling, which would create a pool of enemies that the system could pull from and recycle them when they are in view, creating the illusion of having a dense crowd.